audible, Dr. Abhinay?
Yes, sir, you are audible, sir.
Okay.
Okay, thank you, Dr. Abhijit. So first of all, I also want to give a big thank you to Dr. Sharma, because just I sent on message and immediately he replied, yes, I am ready. So I am very happy to see that message. Thank you for that. So now I'm going to introduce in front of our audience Dr. Anup Kumar Sharma, and few of us maybe know, because he one of the participants in our last conference, and from that conference we have in our relation, and so still is going on. I hope it will continue in future also for our future collaboration research, whatever. So Dr. Anup Kumar Sharma is the assistant professor in Department of Mathematics, NIT Raipur. He has obtained his MSc, MPhil, and PhD from ISM Dhanbad, India, and he was faculty at VNIT Nagpur and NIT Warangal also previously. So Dr. Sharma is a recipient of UGC Research Project Fellowship. He is a lifetime member of the Indian Mathematical Society and International Association of Engineering, Hong Kong. His research interest including sampling techniques, statistical interference, and missing data, and data science, Bayesian analysis, and machine learning. He has published more than 20 papers in international and national journals. He has also organized national workshop on statistical method using R and AICT, ATL, FDP on data science in R programming. So this is our Dr. Anup Kumar Sharma. Now I'm going to hand over to Dr. Anup Kumar Sharma, and he's going to give you one talk on the non-parametric statistical and data science. Okay, now I hand over to Dr. Anup Kumar Sharma.
Okay. Thank you, sir, and thank you, Siksha Anusandhan University, who has given me opportunity. This Department of Mathematics given me opportunity for this talk. And here in this platform, I want to share some knowledge in this statistical data science, which is specified in non-parametrics. So in non-parametric, this data, I would like to some little bit touch with the parametric data. So in non-parametric, when we talk about the parametric and non-parametrics, so so what my mind is just focus on the test, means testing of hypothesis. That generally we study our testing of hypothesis in parametric and non-parametrics. In other language, means in other theory, what we see, the parameters, means there is the two types of sample parameters and population parameters. So population parameter is what the statistical measure is based on the population observations, and similarly the same sample parameters, which is based on the sample observations. Population, for example, like population mean, population variance, these are value calculated based on the population observations. Similarly, sample mean, sample variance, sample standard deviations, these are based on the. So here, these all, so far we have calculate these values, data. So data is following some distributions. Okay, data's what following some distribution. Then you say that it um, it has some distributed data. Okay, so in this, what we observe, what we calculate the parameter, that is parametric, and when the data are is assumed non-distributed, means free of distribution, means any probability distribution. So when we then we include in the non-parametrics. Okay, so in this non-parametric statistical data science, we are focused in the testing of the data. So testing of data, that means the given information is correct or not, means we need to accept or reject on including some error, or error in the sense that means 5%, means 5% data is not contributing in the our research. Okay, so contents we have made here: parametric, non-parametric, about something I want to take, and Whitney U test, Driscoll Wallerstein, sign Wilkinson, sign drawing test. These are all means these all three tests which belongs to non-parametric test. So first we know about the parametric and non-parametric. I sub little bit of sentences I said already about the parametrics. So parametric is what? Sample size small or large, whatever the sample size small or large, distribution of outcomes we generally approximate is normally distributed. Means when we talk about uh, the data, like when we're tossing a coins, throwing a dice like that, these are random samples. So this distributed, these data follow the binomial distribution. The defective items, number of accidents follow the Poisson distributions. So these are means small or large, we are specified. But we any population data, we have the huge data and we'll take the samples. So itself it is follow the normal distribution. Okay, so we can assume this data is following the normal distribution. Then what we apply the test, that is called the parametric test. So this is the part of this parametric and non-parametric test, the part of the statistical inferences. Okay, and statistical inferences, there are two parts. One is the estimation, and other one is the testing of hypothesis. Estimation, that means the data are available. We are estimating the population parameters based on the samples. That is the one part. And testing of hypothesis, that means information is available. We need to check it is correct or is true or false. Means at what extent it is true or what extent it is false. It is acceptable or not. Okay, so means in this example we can take means testing of hypothesis. Generally our focus in the testing of the information. Okay, so when we take a just like coordinates we are using in our general life, so there is the one government or company, there is the mentions that there is the sugar in the 100 ml is something 10 grams. Okay, this is my assumptions. 10 gram is if more than 15 grams it is bad for health. But what happened due to some companies, due to machine error something, they have included 16 grams, 17 grams. So these we can do by the sampling. And based on the some test, we can check the given items are coming the market is good for our health or something. So that we checks under the testing of hypothesis. Okay. So here we given for the parametric test, there is the JET test and T test. Who are in the master degrees, who are BTech sums, I think, who have done JET test and T test. Okay, some more tests are there, F test. So these are coming on the parametric. So the chi-square test, these are not coming in the parametric. They are coming in the non-parametric test. Goodness of fit, these are non-parametrics that have no specific distributions. Similar way, just the data is not following the normal distribution. This arbitrary distribution, you can say. Okay, then this means the test we conducted is called the non-parametric test. So the non-parametric test, example, we apply the Man-Whitney, Kruskal Wallis, and like Wilkinson's rank test. These are coming under the non-parametric test. So non-parametric test when we apply. So non-parametric, that means there we not consider their mean, variances, standard deviation. We are not considered, but we are considered their median. Okay, ranks. These are considered. The non-parametric is applicable when outcome is an ordinal variable or ranks. Ordinal then is true, false, like men, females, and we are giving some like low, high, medium, mild, like that such type. So one figure is there, no pain and agonizing pain something. Suppose I'm going for some treatments, some medical treatment. So I'm their surveys rating for the pain, how much you are getting. So 0 means no pain. Okay, so 1, 2, like we can also 10%, 50%, we can giving the some ratings. On other case, the data has some in ranks. Okay, when we are taking in ranks, then the non-parametrics are appropriate. These are the three cases I have shown that the means non-parametric tests are appropriate. It's not here the compulsory we are using that one because statistical totally based on the data approximations. Okay, so that on that basis we can take a decision further what to do, what need to do, what need to improve, what need to means remove. Okay, based on this one we can make according to our need. So this when there are definite outliers. So outliers, that means you're understanding. Suppose I have some tendency in data, but there is the one fault. Suppose in the classroom where I'm teaching the mathematics, students are getting mostly like more than 60% marks. Like that, I've said the question papers and giving the marks, but one student getting the 5 marks. Okay, all are except one student, all are getting more than 16. One is the 5 marks. So these the student are coming the outliers. Okay, so so that type of in data we are considered under this means non-parametric testers. Okay, so this line, this is the called the box plot or box whisker plot. In, okay, it has also meanings. This one, this representing the mean of this one. Okay, and this is the interquartiles, the first quartiles, and this is the third quartiles, and this is the second quartiles between this one. So it is representing like the curve is going on when we approximate with the normal. So it is like this way, and it is tail is something coming. Okay, so this is the negatively skewed, means left tail is there. This side here tail and this side here not tail. In normal we are comparing this one. Okay, this is the one data. So here is giving days in hospital. Suppose I'm giving for treatment. So what for some particular treatment something there are approximately 10 to just 11 to 15 days we are discharged. But this point is giving someone is in like 6 days and someone in 35 days. So it's including some outliers in this case. Other case when outcome has clear limits of detection. Detection means that means suppose any person is detected with some viruses and we are measuring the number of some bloods condenses, some words is there. Uh, so here as giving some other means overestimate the noise something for the graph. So here is what limit is fixed, but others are coming not detected. Okay, so it has a clear limits of detection, some other not detected. So in this case we can. So these are the three case we are including, and we have shown here some what is the difference parametric and non-parametric assumptions are. Yes, we can assume parametric, but non-parametric not assumption mean value correlation we are counting Pearson's and experiment we are going. In this case, the data is by default the normal distribution arbitrary. Population knowledge is required, does not require. Interval data also we can include nominal data, variables, attributes, means true, false, like good, very good, like that, this thing. So these are the test because we are showing in the small data. Okay, small data means the sample size we take less than the 30. So that's why we shown in terms of this t test uh, is coming under the uh, parametric test. Okay, so one sample t-test, that means there is a comparison between the sample mean or sample average to the population mean. So there is no any subpart there. Unpaired t-test and paired t-test. Okay, so unpaired, there are two types: parametric, non-parametric. Again here, so parametric is further is student t-test and Wells t-test. Okay, so these are generally is not included in the master degree events. Okay, when we go for some research something, so these are the tests are required for further. Okay, so generally up to we have studied the BTech and master degrees like student t-test for the when equal variance are available, when equal variance are not, the Wells test we apply. Non-parametrics, man, Whitney, U-test we are using to test it. And this is for the two samples, two man witness. When we include more than two samples, so there is the Kruskal Wallis test are coming. Okay, means in generalization, just like we are using the J test and T test, but when we come to the more than two samples testing, so we use the ANOVA. Okay, so ANOVA means there is the all sample data is following the normal distribution. Non-parametric, the data are not following the sample distribution, but we are taking the ranks. Okay, pair t-test, parametric, non-parametrics, pair t-test is there. So there is the correlation we include, and with person there is the we use to test. Okay, it has some difference. Okay, one sample is clear. Unpaired t-test, that means the two data, the two samples are independent. Okay, so independent means to say unpaired data. So means to say when we are comparison between the IQ level, female and male students, like that. Okay, so these are the independent. Okay, the unpaired samples we are conducting the non-parametric test or parametric test. This is the unpaired two samples. Paired t-test, that means one sample is repeated two times in different two times or under different two conditions. Like just we have some chemical reaction, some things we are changing two temperatures. Okay, so these are the same thing we consider like uh, means pair t-test. I'm giving the example. Two samples. What type of these two samples? Means here the two samples. Just like I'm taking the class before notes, before I'm teaching, preparing for the some examinations. Okay, before coaching they have something marks, and after taking coaching they have marks. So these are coming under the peer test. Means here elements are same, but their observed data in two different times. uh, we are taking in two different times or under two conditions. Okay, so we have this is about the parametric test, but we are not going to that. But I have written with this t-test is what the student probability distributions and widely used for small sampling, and t-distribution is become the Z distribution, means standard normal distribution when it is approached to the infinity. Okay, and there is the what t and Z distribution. What common is the mean is zero always, but the standard deviation of the t distribution is estimated. But Z standard normal is 0 and 1. Okay, for bigger sample t distribution become the Z distribution something, and these are the distribution is written as gamma function, and it is based on the degree of freedoms. Means the probability curve is changing with the degree of freedom. So they are including the degree of freedom. So here some graphs are given above the standard normal distribution. The red one, uh, this red one is the standard normal, and this is based on the degree of freedom as increases. That means sample size is approaching to the standard normals, and what we are getting the flatter. The curve is flatter here in comparison to the standard normal and comparison to the higher degree of the normal distributions. Okay, we are comparing we done in the these upper degree of freedoms in the rings, and these value tells about the significant value by which we are comparing our significant difference or non-difference. Okay, so this is about the how to find the mean and variance standard deviation by using this t distributions. This is about the parametric test. Here we use this is the test statistics x bar minus mu s upon root n, and here s is standard deviation of group with n minus 1 degree of freedom. Some place you can see here x bar minus mu upon s upon square root under n minus 1. So there s is equal to square root under 1 upon n summation xi minus x bar whole square. Okay, this is the difference of the formula. Okay. So that is the one sample t-test. Means here we comparing the one sample to the population. This is coming under the population. We are not giving any examples. So unpaired or independent t-test already has said something. So unpaired t-test statistical procedure that compares the averages means of two independent unrelated groups. Significant difference or not, these things. Examples are like men and women, whatever we are talking, two groups, buffalo and cow, milk means protein level of milk in buffalo and cow we can take it, and other things we are taking this one. So this is the case when the variance are equals. When variance are unequals, we take the Wells test. Okay, these are the parametric test. Equal variance. So here we are two samples. So this variance we are calculating the average of the variance. That is called the pooled variance, and degree of freedom is this one to calculate the significant value, and the its those are given all the things. When the equal not equal variance, so in this case the Aspin Welch unequal variance t test, and here degree of freedom is what this is calculated by this formula. Okay, so these are we have just given glimpses of the parametric. Okay, I think you have seen these all the formula. Unpaired. Now we come to the main important, the Mann Whitney U test. So Mann-Whitney U-test is considered, means this state is used in for non-parametric testing. Okay, in this case we compare two independent groups of the samples where the samples are not following the normal distributions. Okay, and sometimes it is also called Wilcoxon-Mann-Whitney test, Wilcoxon-Rank-Sum test, because here we include the ranks. Okay, this is all. This is about the Mann Whitney test. Something has key. I will tell after this examples. So examples. What I discussed, because we have limited time, so we are just discussing about the such type of test which can be useful for the research scholars and some master degree in BTech can do in project. Okay. So example is what one clinical trial design investigate effectiveness of new drugs to reduce symptoms of asthma in children. So there is one clinical trial is going on. So there is the two types of drugs we are using, and there is a patients are 10. They randomized to receive either drugs placebo. So one term is the placebo and new drugs we have. So in this case, we are calculating the record number of episodes of shortness of breath over one day. So when we include this, when we give to the patient this placebo or new drugs, so we see the episodes of shortness of breath is number of breaths is what short breaths we are counting. Okay, just like in one week, sometimes in any time started breathing is very low. So that episode, breathing is taking 1, 2, 3, 4 times, and after sometimes they feel better. Okay, so that is the one episode. Like, so we counting in the seven, there is possible five. So placebo is the drug. So in this drug, we cannot believe fully. New drug, that means scientifically prove something. Okay, you see the placebo 7, 5, 6, 4, 12 are coming because we are using, but we cannot believe on this type of drugs, placebo. A new drug that is scientific. So you can see it is the effect on this. So we are here. So such type of things data is not following the normal distribution. We assume here, okay, like so we check this one. Is this data means is the difference between difference means the two drugs is effective for treatment or not means new drug is effective for treatment for the children or not in this case. So here's the question: is there a difference number episode shortness in terms of episode shortness of breath over 1 week period in participants receiving new drugs compared to those receiving the placebo? So this is the questions. So when we take this data like 1, 2, 3. So here 4 is repeated for both the placebo and the new drugs. So that's why frequency is 2 here. 4 is repeated and 5 one time, 6 2 times 7 like that is there. So placebo is we have written here new drugs. Now we are ordered because when we are giving the ranks, so that means the ranks how we give smaller value we give the 1. Okay, 1 rank. Okay, because rank in that case not the highest because there are two way we can ranking the highest. Suppose there's a dance competition we are going, smaller value rank one is not, there is the highest value rank one. So here the breathing that should be small, so that's why I start with the one. Okay, so what we are doing, we are arranging in order. Okay, the new drug one is included, so we start here one. 2 we start here 2. 3 is there, 3 written in that column. And 4 is also, but 4 is repeated in 4. 5, 6 is repeated, 7 plus. Now we are giving the ranks. So rank started with a 1, 2, 3. Now 4 is repeated, 4, 5 ranks, 4 and 5, but both the value is, so we give the average value means 4 plus 5 by 2 means 9 by 2 is equal to 4.5. So these value we are providing. So next 4, 5 is completed 6, 7 and 8. So 7 plus 8 divided by 2 is 7.5. So we are giving further is 9 and 10. These are ranks are given. Okay. So after ranks, obviously we know that the means when we testing of hypothesis, these are the means procedures like we have to assume the hypothesis that what to do means two population are equal versus two population not equals we are checking means when we providing two data means two these medicines, so its result in that case means the number of episodes uh, in both the medicine is significant different or not. This we are checking. So like we say that test statistics, so here is that test statistics denoted by u. Okay, and we consider the small value of the test statistics. Okay, so you can say U test also or Man Whitney U test. Okay, this is the formula N1 into the N1 is the sample size of first sample into the second samples minus R1. R1 represent here rank of the first sample and R2 is the rank of the second sample. By taking these values, all this one, we have U1 is 3 and U2 and 22. The statistical value means calculated value of U is here minimum of this U1 and U2. So our U is 3. Uh, Here we critical value written here. So however here U is minimum of U1 comma U2 So means minimum of 3 comma 22 is equal to 3. So that means here u is equal to 3. Since the critical value is 2, so these things we calculated from our table, that is the Man-Whitney table. Okay, and one thing is here, we are taking, this is the our assumption main things, we are assuming here a level of significance. Here alpha representing 0.05 is the probability of rejecting the null hypothesis. Okay, alpha what is probability of rejecting the null hypothesis, or level of significance means L level LOS is equal to 5%. Can say. Okay, so on that basis, like Z test, T test, we calculated here U alpha value. Okay, so in this case, there's a two-sided rejection area, just like in the Z test, two-sided here, like it is normal, so two-sided. So in this case, what there is the line, rank line. Okay, this is the U alpha, and here is the critical region, and means this is the rejection area, rejection, and here acceptance value or area you can say. Okay, so that we calculated from the table. The table is want to show. Let me table. This is a Man-Whitney table. Okay, so you can download from the Google also. This is the N2 in the rim value, representing the size of the sample here. And this is the into the second sample, and with the first sample. Alpha is representing the means probability of rejecting null hypothesis, or you can say level of 0.05. This is the 5%, 1%, 5%, 1%. So we are assuming here 5%. So our sample size in this case we are taking what 1, 2, 3, 4, 5, 5, and this is also 5. So 5 this one sample, first sample. Okay, this is the 5, and again this is the 5. And in this case, this hour in 0.5, this is 2 is coming. Okay, and it is written there 2 tail, it is not the 1 tail. Okay, so what we take alpha 0.5, so this is 2. In 1 tail, it is different value. Okay, it is still a 2 tail testing. So we are conducting the 2 tail. So we have here critical value. This is our critical value. Means, and the U value, that is here U is equal to 3, which is greater than U alpha is equal to 0.5 is equal to 2. So what happening? This is the U alpha, and this is the critical region, and this is the 2 is coming here because this is 2. So we say that H naught is accepted. So H naught accepted, two populations are equal versus means for both medicine has same effect by 5% error, means 95% data is contributing for this one. Okay, in conclusion, what we say, so two population of number of short breaths are not equal. However, this example, failure to reach statistical significance may be reduced to low power. That means the new drugs we are implemented has a low power. Okay. So this is the Man-Whitney test. Here is the formula simulator I'm going to we can use here and to conduct such type of examples. In this case, Man-Whitney U test, it has some properties or key concept we can say. So the range of U the range of U is maximum N1, N1, N2, and greater than is 2. Okay. So when its value, okay, see this U1 plus U2 is always N1 to N2. So this value is minimum 0 and maximum N1 to N2. Okay. And about the rating, you can range from 0 to 25 for this problem because 5 into 5 is 25. Whenever you support with the research have an alternative hypothesis, and we reject H naught if U is small. Okay, but small. This is the sense overall. But when we are comparing to the critical value, so then actual we get the rejecting or accepting things. Okay. Now we 5. Yes, I'm audible to all. Yes, am I audible? Yes. So we have completed that the um, unpaired uh, non-parametric test. Unpaired, that means two data independent. Okay, two data are independent. Next is the classical volatility because continuation of this one, because there we consider only two data set and here we are considering more than two data sets. We say that within K population we have drawn K samples and their sizes are different N1, N2, NK, like. Okay, so total is N value is N1 plus N2. So maximum means range is coming from 0 to like that in the mind witness test for comparison to the significant values here, and that is the key concept or you can say properties of that one. Okay. Yes, I'm audible to all. Okay. So, classical Volley test is a generalization of the non-Whitney U test here. We are consider here more than two samples. Okay. So in this case, and this is called the H test also. Okay. So in this by this problem, we are considered with the examples because better to understand. A clinical study design, all the things we have taken example like in medical, okay, clinical albumin levels. Albumin, we know some people. So, okay, means protein level is increased. Albumin level means it represents the protein in the blood. Okay. So adults in following diets with the different amounts of protein. Low protein diets are often prescribed for patients with kidney failures. For some reason, we are using proteins. We are limited 5%, 10%, 15%. Albumin is the most abundant protein in blood. Means to say its concentration in the serum measured in grams per deciliter. This serum albumin concentration are also used to assess whether patients get sufficient protein in their diets. Three diets are compared, ranking from 5% to 15%, and 15% diet to represent typically American diet. Okay, these are extra things. The albumin level of participants following each diet is shown. So 5%, 1, 3 people, because we are considering the small data. Okay, not in large data. We consider the large data. We need to include some jet test, Okay, so that was strictly we are large data, that means approaching to the normal distribution. Okay, so here is the three peoples like giving 5%. So we having 3.1, 2.6. These are albumin level. When we are providing means diet having 5% protein. After that, when we check albumin level, we getting the 3.1, 2.6, 2.9. 10% running the people's 1, 2, 3, 5 people. So we have the this albumin level, and 15% is high protein. So like the 4 people, we having the albumin levels. Question is there a difference in serum albumin levels among subjects on 3 different diets? Means if these 3 diets when we implement to the patient, so what we see affects means it is reduced albumin level or not. That's it. So by inspection means by in means common sense 15% protein that have higher albumin levels, those 25% like obvious this one. Here the sample size is given n1 into 5, and again this is the testing of hypothesis because these are the means what we are the things we are discussing. The testing of hypothesis. So here we need to assume null hypothesis, alternative hypothesis. The 3 population medians are equal. Means not to say medians means to write in hypothesis like median. We are not calculating here medians, but like parametric we always say mean. Here medians. We can calculate the medians. Okay. 3 population medians are not equals. We are right. Or simply we say 3 populations are equal versus 3 populations are not equal versus, or we can write like null hypothesis, alternate hypothesis. So albumin levels are equals in all the 3 population, and in this case the albumin levels are different. Okay, mutually different in all the 3 populations, like alternative hypothesis we can write. Okay, so many ways we can write in this case. Here we consider level of means pre-assumed, we are assuming here 5%. This is our error we are including. Okay, so next is like same steps are we are following. This is the percentage. Total ordered we are writing 2.6, 2.9, 2.9, such type of things. Similarly, ranks we are writing 1 because it's repeated 2.9 to 2 times. So 2 plus 3 divided by 2. When 3 times repeated, so like 2 plus 3 plus 4 divided by 3. So we are giving rank such numbers. Okay, same values have same ranks, but that is the average of consecutives assigning ranks. Okay, 4 is single, 5, 6. Like those are single, those are in points, that means repeated here. 17. It's not repeated other things, these are the rank. Also we can find the sum of ranks because it is needful in the this testing order. Classical volleys this is represented by H, means this statistics of classical volleys represented by H and defined as H is equal to 12 upon n upon capital N means total sample size, and that means total sample size here, and this is the summation of all ranks divided by corresponding samples. Minus 3 into n plus 1, these are the formulas given by the classical volleys. Okay, when we calculate, that is the calculated value of H. Okay, so these R1 means rank of first sample, rank of second, rank of third. Okay, and after we are getting the 7.52. So critical value from the table, you can we have a table like that, so we need to skip that things. So critical value, you know how to just collect the table. From the table, you just compare with the sample size and on the significant level. So we having this one, this H alpha 0.05 is equal to 5.656, and here H calculated value is equal to 7.52 something. So what we see, H calculated value 7.52, which is greater than H alpha means H alpha is 5.65. Okay, which is greater than among three different diets. So conclude there are a difference in medians among the three different diets. Okay. Um, One thing is here. Some what happening? Just to see in the case of this man Whitney, there we consider the value. Here one thing, something different. So in this case, difference in medians albumin levels among the three different diets. Difference is not here because in this case, this is the 5.65. This side is the critical region, and this side is the 7.5. Here is 7.5. So this is the acceptance regions. Okay. So there is not, we need to cut here, not difference in median levels among the three different diets. This is our right conclusions, not difference. Okay. So that means what we providing, because this is maybe possible by the what we sample we drawn. Okay. Just like 5% error we are concluding, that means that 5% data are included in such type of thing. This is the one sample, which is based on the one sample. It is not sampling. Sampling with the good result. Okay, means mean of sample mean. On that case, it's giving good result, but it is not happening here. We are taking the one sample here. So that's why we can see that in this sample, we are not getting the appropriate result what we need. So what so far we have discussed on the unpaired data, independent samples, independent data. Okay, and now we are going to discuss on the paired data or correlated data, dependent data. Okay, so here two groups means two samples are related. Two sample related, that means samples data is observed in two time or in two conditions. Okay, like here one example I have written. So productivity level of his employee means any manager like want to improve the productivity level of his employees. Um, uh, Means due to now seeing that productive means not the current situation is bad. I decided to conduct a training program for all his employees increase their productivity. So this so that we check because here data is dependent. The same persons, but training we are applying. So this is here pure data and dependent data. In such type of things, we apply the uh, Wilcoxon test. Okay, but previous that one I given about the T test. So T test, this is the insight we included here correlation. These are not studying the BTech and books. Mm, okay, like some other term. Generally, in this case, we consider as a unpaired data. Unpaired data in generally books, we are not including. This is the standard error. SE of minus 2 bar. Okay, so this included the correlation between the first group, second groups, because they are dependent. When we say the dependent, so that means there is the correlation is coming under. This coming under the parametric set test. So in pair is what there is the considered two tests like sign test and Wilcoxon sign rank test. Sign test is very simple. In this case, just we means which is based on the plus and minus means the difference of two data based on the plus and minus. Okay, it is also compared with the population. So population data is fixed. Sample data is different. So there is the what is the sign is when we subtract is giving the positive one means to say suppose H naught is equal to some we are saying that median is n naught is equal to 5. Okay, and I have the rank something 1, 2, 4, 8, 9, 10. So we are finding the corresponding rank, means sign. Same. So 1 minus 5 is minus. So we writing 1 minus 5, then it is the minus. Okay. Next is 2 minus. So minus, we are getting 4. This is minus. 8 minus, this is plus. We writing means we are getting positive value, but we writing only sign. Very simple test. This is plus and again plus here. So now we counting the number of this minus sign and plus sign. On that sign we check their test. But this test is not that much success because it's giving final result is not that much good. What is the drawbacks in this case? The drawbacks is that we are taking only minus and plus sign, only sign, but we are not taking the value, means magnitude. Magnitude is in negative is how much? Is minus 1, minus 2, minus 3. In plus maybe 5 and 6. So it's contribute properly to test the means check the data significant or not significant in this case. Okay, all the things I have written, but I said in all of my words. So already I said all the things I have written. Sign test, simplest parametric test measured for pure data. Okay, sign always used for the dependent data. Okay, and sign is difference in scores only. In signs of difference scores, plus minus. Null hypothesis, the null is true, then accept the C approximately half of the difference positive and half of the difference is negative. It is true. This is true. Research happens alternative hypothesis. We expect to see more positive difference. Okay. So with immediately with the one example, sign rank test. So here is the word child. We have the 8 number of child. The before treatment, we are measuring what the things. Clinical investigation as effective new drugs reduce repetitive behavior of children affected with autism. Something autism in there. Behavior treatment untreated. 8 children with autism enrolled in the study. Each child observed by study physiologist for a period 3 hours, both for treatment and then again after taking new drugs 1 week. The time that child engaged in repeated behavior during each 3 hours observation period measure. It behavior is good because here the childs are same. Before treatment is what we are getting the autism, autism, and after 1 week after giving the treatment, so we are getting something. It is fall in something. Okay, so these things we check by the scientist. Scientist same before and after. So we are subtracting 85 minus 20 positive value. Okay, these are. But we are taking only sign here, number of positive, number of negative. Same way, uh, here 160 value, 65 considered as outlier. Median of difference is 0 versus difference is positive. Alpha is it's coming above. See, we now here we taken here plus plus minus plus plus minus. We observe 2 negative and 6 positive signs. Okay. And critical value in this case by the sign test there is a table. You can calculate there. We have such a table. Positive value means. So again we see the minimum number. What is the minimum number? Is positive sign or negative sign? When is equal, then H naught is accepted. Okay, that is the one by the theoretical value, but based on the critical value. Now see, reject H naught is smaller of the number positive or negative less than equal to. It is written that we do not reject because 2 is greater than 1, because critical value is here for sign test is 1 and we are getting 2 greater than 1. Okay, and consider this alpha level of significance. So we do not reject. That means what we are treatment are giving is no change. Okay, so these treatment what show there is improvement repeated behavior are taking drugs compared to before. We do not have sufficient evidence at alpha this one to show that there is an improvement in repeated. There is no, we have sufficient evidence in this case. These are the means p score we are calculating, but because comparison of the value statistical means statistical value with the critical value we have considered, and here is the p score, and p score based on the minimum number of that plus sign, a positive sign or negative signs. So out of this, there is the only two positive signs. So we are getting the probability. So in this case, we are getting is more than 0.05. So when it is p score is greater than this level of significance, the null hypothesis is not rejected. There is no difference. Okay, so treatment does not change anything. Same thing we are getting. These are the calculation part is here. We have done, but due to limited time. Last is the Wilcoxon test is the why it is included, because that it is important. Before Wilcoxon sign test, we need to study about the sign test. Same, but here we are taking the magnitude of the plus sign and negative sign, plus sign and the negative signs. So that contribute properly way to check the significant difference or not. These things we are coming in Wilkinson sign test. We have taken the same data. Okay, same data is here, and we are just like we have taken the same data 10 minus 10. We are getting the difference. Now we take the absolute value, and now absolute value we have taken and arranged in the order, and after taking the ranks. Okay, this is the sign minus something is there. So null hypothesis difference is 0, median difference is 0 at this level of significance. This is our research hypothesis. And what we are getting when we are taking the plus and this is minus, this is the sum of the ranks having the negative sign, means minus 3 plus minus 4. So it is represented by this one, minus 1 plus minus 3 is equal to minus 4. And similarly for the plus 1, we are getting the 32. Okay. And total rank is was 32 plus 4 is equal to 44. So critical value, same way from the table, as we know that J table, T table, here is 6. And decision is this one. Okay. In this case, we are getting the 4. Minimum value we are consider again. And this is the 4 is less than 6. When it is 4 less than, means this is the 6. And here the critical region. So it's coming in the this region, critical region. So what's statistically significant evidence? Okay, Yes, sir, I'm audible. Sir, what happened here? Sir, heavy rainfall due to power cut. Okay, and today is Saturday, and all office are off. So I think generator is the very less chance to on, even the heavy rainfall and storms are coming. And what, sir, if any, sir, it's better to weigh some any doubts. If anybody can ask, because that is the last portion. Only our programming is left there, but unfortunately, due to power cut, and um, so came in depression. Yes, sir.
Okay, good afternoon, everyone. So I would like to ask one question.
Yes.
So actually, I was going through your research papers, and I could see that you are now working in population mean phase sampling,
Yes.
missing information. Uh,
Yes.
so actually, I would like to know that what kind of work means have you actually done there? I have not gone through the individual papers till now. There's actually one article is accepted. It is not still available in the internet
Okay.
under missing information at random. I found. So what was about
Yes.
that?
Yes, I'm getting. You asking about that means
The
paper
research.
that missing.
Yes,
Okay,
yes.
missing data. Generally, what happened? The data is not available in the full place, like when survey is going on and what the thing. So missing data, we have to fabricate such that the missing data is filled by the other means responding data. Okay, so there is a technique like Hansen Horwitz technique is there. So here we use Hansen Horwitz. I had one paper there, Hansen Horwitz, in the H occasion successive sampling. Okay, but when you see the papers of the variance estimation, that is the parametric on there. So
Yes.
there we use the distribution. Like distribution, it is type of binomial distribution. There is the non-responding elements have like we are taking, because non-responding is very less. Responding should be more. So at least two is non-responding. When it is the like data out of R,
Yes.
we are taking two data, three data. So it's follow the binomial distribution type. Okay. So
Okay.
so with that distribution, we are including the means approximation of the means sample data, means sample. There is the with the error, and we use the mean square error, and we with the checking of the biasness,
Yes.
and
Yes.
we are finding the optimal mean square error, and with the comparing with the responding one, even in the missing data is comparing is good result. Means in relative efficiency we are checking in the efficiency case, give good result. So there we are taking the distribution. Without distribution we can go through, but it is better when we are taking the chance 5% to 10% to what could be the efficiency of this data, means estimation of the parameters,
Okay.
in
So
terms of estimation of
that's why
parameters.
you have taken it as random because it is following
Random.
some distribution.
Random means any data, means could be non-respondents. So we are means included with the probability distribution, follow the distribution. So there I have taken the binomial, you can use some other distribution also.
Yes.
Okay.
Okay. Okay. Thank you, sir. Thank you so much.
Hello, Doctor Anup. That's only the visit here. Actually, you called me. I did not pick up. Any issue at times?
Yes, sir. Actually, what happened? A power cut. I'm using power presentation. There is one thing left is our programming in that all the types of my topics. Okay,
Okay,
but
okay, okay.
unfortunately, what it's a heavy rainfall is going on outside
Okay.
of. So and
Actually,
even
just
today
I kept
starting.
my phone in the text table, then I went there. That is, I am outside there. That is why I didn't pick up. Sorry for
Uh,
that.
and one thing is today Saturday is college is closed. Means to
Oh, yes, yes, yes.
just we are so rain is going on, so power is not like that. Even
Okay.
not I. So unfortunately, some things I left, but I will send. Get straight
Yes,
to.
yes, yes. Actually, one of our faculty, Alaka Tipati madam, she is asking me that she is very interested in your presentation. I
Hmm.
think she is here right now. I do not know. Just now she told me that she is very impressed with your presentation, and she asking me, can I get this presentation? So I'll talk with her. That means obviously sir will help you. And if we want to do some collaboration, you can contact with her also. No issue. I said
Yes, sir.
like this from your side. I think it is okay.
Yes, yes. No issue, sir.
Yes, yes.
Collaboration make improvement of our society and
Yes,
also
yes, yes, yes. That is
youth.
why on behalf of you, I say that I will be always be, I think, ready to do some collaboration research. If we interested, we can contact.
Yes, sir. Yes, sir. I'm always, sir. I will
Yes,
share this presentation. Also, the R codes for that one. Also.
yes, yes, yes.
Yes, sir.
Okay, now, or visit, please.
Yes, sir. Yes, sir. Thank you, sir, and thank you for the students, faculties, and scholars. So who has keep patience to listen my this discussions, these topics. So it is the helpful for because these topics not taught in the master degree, but those who are people working non-parametrics can by this basic can do research. Okay. So
Okay.
uh,
Finally, we can say again thank you from all of us. Okay,
okay,
then
sir.
we can end, right?
Yes, sir. Thank you, sir.
Okay. Okay. Okay, then bye.